and I in the northern hemisphere.
Unfortunately, right?
Yeah, I know it's already feeling like it's getting a bit cold. I got my jumper on again. So, well, hopefully, we recognize some of you already. So, if you're joining for the first time, we have a chat here. So, if you say where you're from, then we can figure out which parts of the globe we got covered. So, I'm here. I'm in London. So, I'll post me. Change it to everyone before you hit send. Hamid, Shao. Who else have we got? Let's have a look.
Welcome. And I see
Alon is
so.
here.
Yeah.
Ramazan is here.
Welcome, Amazon.
So if you have any questions while we're doing this, obviously you can use this chat. And then there's also the Q&A tab as well. So whichever one you prefer.
Welcome, Larry.
And
Nice to see you again.
it's going to be on YouTube as well, but I'll give you the link so you can share this with people afterwards. I'm going to paste that in now. So if you want to watch this afterwards or share it with somebody who's not watching live, then that's the link.
And special welcome to Robert Schulze. Nice to see you on a call.
Yeah, many of the features, I guess we can thank Robert for his coding, his team's coding. So we got London, we got India, we got Portugal. Okay, we got Turkey, Canada, India. India must be a bit, it's like kind of like early or a bit late evening.
What is the most unusual place today?
Yeah, anybody got an unusual place? What's the most unusual so far, would you say? Well, Amsterdam, that can't be unusual. That's you.
It is so usual. Boring.
Tyler's at Tech BBQ. Guess is that in Amsterdam or is that?
Hopefully, he has a good BBQ.
Yeah, Greece. Greece is good. One day we're going to get someone who stayed awake all night for Australia. That'll be the day. Right, I reckon. Shall we shall we get started then? I guess we've probably got everybody who's joining here, so it's a few minutes past. Let's do it. Do you want to share your
Start.
screen and then I'll. Yep. And I can see it. Or I can see Zoom requesting something. Yeah, then I
Allow.
can see.
Okay, it should work.
Great.
Okay, so this is ClickHouse release 25.8 LTS. And LTS means long-term support. This release will be supported with patches, backports, bug fixes for a year until August 2026. So if you want a stable version for production, this is the time to get and install the new release 25.8 LTS. And today we have most of the time for new features, a few minutes for Q&A if we will be lucky, but also we will have a guest presentation. I will not tell you about what it will be. It is a surprise for you. So we have 45 new features, 47 performance optimizations, and 119 bug fixes. It is probably the largest amount of bug fixes ever in the release, because this is LTS and we have to prepare carefully. So let's start with something small and nice. Small and nice features. What do we have for you? And the first one, probably quite boring, but let me explain. It's about the virtual column named underscore table. And we already have this virtual column in previous versions, and it is used to identify the source of data when you use merge tables or merge table function. Like in this example, I created two tables, A and B, inserted some data, and then read from these tables using this merge table function that merges this table by a regular expression A or B. And with the table virtual column, you will get simply a string with the table name where the data came from. In the new release 25.8, we extended this feature to support any type of tables. So not necessarily merge tables, it can be just a regular table, and it is especially useful if you do a complex query with union all. Just add a table virtual column and you will get this simple and nice. Number 2, external disks for temporary data. It's about complex queries, heavy queries, queries that don't fit their temporary data in memory. Like you do group by, but this group by has to aggregate over tens of billions of records, and it will take like hundreds of gigabytes or even terabytes of memory, and that's why these queries automatically use external memory. This is true for group by, for order by default, and for certain types of joins, not by default, but under certain settings. And until recently, ClickHouse could only use local disks for temporary data. We have made a small one-line change, and now ClickHouse can use any types of disks for temporary data, even S3. Let's suppose you have a server without disks. It can be a cloud machine, it can be whatever, ECR, AWS Lambda, it can be even like something like Blade servers, but you have external storage, S3 or S3 compatible storage. So you can use these servers to process data, process queries that don't fit in memory, even with temporary data. Just do a tiny modification in the configuration file, and that's it. It will work this way. Now something more interesting, and it will take a few slides to explain what is it about. And probably some of you waited for a long time for this feature, so if you are among these people, please let me know in the chat. I really would appreciate if you waited for this feature. So now we have integration with Arrow Flight. It is experimental, and let me explain what is Arrow Flight. It is a protocol for data exchange for queries on top of gRPC that uses Apache Arrow format. And Apache Arrow format is very similar to the ClickHouse native format, but more interoperable with other systems. So it is good for interaction between different column-oriented databases, like ClickHouse and what else? What else does support for Arrow Flight? Probably something like Dremio, maybe Databricks, I don't know. So now you can easily connect these systems in efficient way. And the integration comes in both ways. ClickHouse can query external data sources, external databases using Arrow Flight, and ClickHouse itself can serve requests using Arrow Flight protocol. So ClickHouse embeds Arrow Flight server. Let me explain in more detail about the server integration. In the configuration file, you just add the port number and SSL configuration, which is optional, and the server will listen on this port to this mysterious Arrow Flight protocol. It supports both put and get commands, so you can do selects and inserts as well. And about the client integration, you can use it with either table function, Arrow Flight. It is simple to use, just address and dataset name. It will automatically derive data types and process this data on the fly, or with a table engine that is named Arrowflight, so it will create a persistent table in your database. Looks nice. Mark, are there any people who waited for this feature?
I don't know whether they knew they were waiting for this feature, but there was lots of people asking to be able to transfer data in Arrow, right?
Yeah,
So
and
this is cool. Yeah, I was playing with this. It's really nice.
does it work? Because I
It
don't have
does.
a okay, I will trust you because I don't have a demo of this feature today.
But
To
it's
be
but it's kind of fiddly to create a server like from some other data. Like whenever I was looking for an example, it's always like a lot of boilerplate code you have to create if you just so I was just trying to make it share like a Parquet file of the flights as an Arrow server. But you have to basically have all this code just for your one line. So but I haven't tried the ClickHouse as a Arrow server yet. Arrow flight
you
server.
I used AI to generate this server, and you know what? AI did not work.
Yeah. It didn't work for me either. I had to then try like a few times fiddling around with it, and then eventually it sort of worked.
Yeah. Okay, what else? A new output format, which is very simple. It outputs just a single line, hash output format. So you write select something format hash, and it will calculate a checksum of the result. Like in this example, it is 128-bit. It depends on the order of the result. So make sure to include order by in your query. And the purpose, probably for tests, probably for some monitoring, just to check that the result does not change. Easy and nice. And this feature is more interesting, more sophisticated. It's about writing data to either S3 or Azure Blob Storage or files with Hive-style partitioning. We already have support for Hive-style partitioning, and if you follow every release call, you remember it was somewhere in January this year. But now it is extended and slightly rewritten, refactored to also support writes. And you use it as follows. First, enable the partition strategy, name it Hive. You can switch between the old partition strategy, like classic one, which is named wildcard. It is not as convenient as the new partition strategy, so most of the time you will just enable this. And what it will do? ClickHouse will automatically create a directory structure, or in the case of S3, it is not about directories, it is about these names that look like directories. And create multiple files. Let me show you. So let's suppose we have a table partitioned by country and year. And we have two countries and 2 years. And after we insert it, two files exist, and the directory structure look like a prefix, then key value pairs of your partition keys, like here, and then some strange name dot parquet. And parquet, you can change it to CSV, TSV, any format you like. And this magic number, it could be arbitrary, but it has its meaning. It means something. Maybe someone would like to guess. Maybe Mark would like to guess.
What would I guess? I would want to say timestamp, but it doesn't really look like a timestamp, does it?
It should be a time,
Ramazan's Ramazan
but
says UID version 7.
almost. Ramazan, you are almost right. Uh, I would like to send you a gift, but maybe someone will give a more precise.
Come on, we need some more guesses. Yeah.
Yeah, because UUID, even version 7, will look like UUID. Yeah, 128 bits. And here is something slightly different.
Someone says Snowflake ID.
Yes, it is
Ah,
Snowflake ID. And Snowflake ID, by the way, has no relation to Snowflake, a company. It is from Twitter, if I recall correctly. And I don't know why it is named Snowflake, but yes, it contains a timestamp. So Mark, your answer is also correct. Inside it is a timestamp. So it is pretty convenient, works out of the box. You can decide if the data files, each individual Parquet file should also contain these duplicate columns, maybe just for convenience. But to save data, you can omit these columns from data files. They will be just in metadata files. And when you enable this feature, also reads, selects will automatically use these columns for filtering, or you can just select them. Okay, now about protocol compatibility. You know that ClickHouse is a polyglot database. Uh, I might ask people in this call, how many languages do they speak? I speak maybe 2 languages, but not this is not entirely true. Mark, what about you?
you know how many I speak? Barely one.
Okay. Yeah, sometimes I think I don't speak any language properly. But okay, ClickHouse speaks native TCP protocol, HTTP and HTTPS, REST API, and ODBC and JDBC drivers are based on this API. gRPC protocol, now Aeroflight protocol, Zookeeper protocol. So ClickHouse can transmute itself into ClickHouse Keeper and it will speak Zookeeper protocol. But also it speaks MySQL wire protocol and Postgres wire protocol. So you can take MySQL client and it will perfectly connect to ClickHouse. You can take Postgres client and it will also connect to ClickHouse. But the problem is this compatibility is not 100%. It could be like 90%, but now it is closer to 95 because now Postgres protocol supports the copy command, which is often used to load massive amounts of data. So you can use your favorite Postgres client. We tested with PG CLI, PGQ, if I recall correctly. Both of them work. And for MySQL, we tested with simple MySQL client and MySQL shell. We extended MySQL protocol to include the remaining information to support the C# MySQL client. I don't know why, because C# also has quite a good ClickHouse client. But now you have this versatility. You can use your favorite drivers. And another small and nice feature. You don't need this feature, but when you need it, it will save you. A new system command to restore database replica. It is similar to restoring a table replica, but for databases, for replicated databases. For the case when you have a distributed system, distributed cluster with multiple ClickHouse nodes and ClickHouse Keeper. And ClickHouse Keeper is a very reliable system. It is difficult to break. It's extremely reliable because it is based on distributed consensus. But I know many people who misconfigure ClickHouse Keeper, like place all the nodes in a single availability zone. And then an incident in AWS and you have to restore and certain amount of data will be lost from the log. And if you use the ephemeral disks, maybe even all the data will be lost. Or you set up Keeper in Kubernetes, but you don't know Kubernetes, and then it's a mistake. Okay, but even if you lost all information from Keeper, you can still restore database replica because data is still there. Only metadata for databases is in Keeper. Okay, now about boring features, boring security features. What could be more boring than security? Probably compliance, but security is also boring. And the first one is about grants for S3 table engine and table function. Let's take a look at the evolution. In 25.6, you could grant or revoke access to S3 data source. So if you revoke it, the user will not be able to do reads or writes, anything, not even list data on S3. So it is pretty secure. But in 25.7, the previous version, we introduced separate grants for reads and writes. So you can grant access only for reads. You don't want anyone to write your precious data to whatever S3 bucket. But sometimes you have different S3 buckets. You have your own nice and good S3 buckets that you control. But the risk is if you give access for writing to S3, malicious users can do data exfiltration. They can point this S3 table function to external bucket that they control. So you want a more granular restriction. And here we are in 25.8. You can grant S3 access granularly for reads or writes to specific regular expressions of S3 URLs. So it is easy to use and it is secure and also convenient, versatile. What else? A new feature is not really a new feature. It's an old feature. It's about specifying custom IAM roles with S3 table engine and table function. By the way, every time I pronounce AWS IAM something, my mood goes down. But hopefully I will go through this slide. Let me explain. So sometimes you have a granular access control on the AWS side or any compatible systems. And this access control is identified by roles. So you use this magic specification and give access to use your buckets or use other resources in AWS. And this is a pretty advanced feature. And until recently, it was only available in ClickHouse Cloud. And it was reasonable. But so much it is reasonable to make it available for all ClickHouse users, because why not? It is not so big feature, but the difference in the code base makes some complications. So why not? And now we have it available even for self-managed users, even basically for everyone. But I know everyone in this call are ClickHouse Cloud users, so either way is fine. And by the way, in GCP, authentication with GCS using OAuth tokens is also available in 25.8. What about performance? And we have a lot of performance improvements. I will cover just a few of them. And the first one is massive. Version 3 of our Parquet implementation. A new, faster, implementation of Parquet basically from scratch. What is the difference in performance? You can look at this chart at the top, and you can see it is 1.81. So it is close to 2 times. Less than 2 times, but more than 1.5. And it is almost uniform across all the queries on ClickBench. But some queries have sped up as much as 2.5 times. I know some queries that sped up 5 times because we implemented a lot of optimizations. Like we implemented support for pre-where. So partial reading of columns, then reading remaining columns, etc. It is natural, but now we have it. Better parallelism, better scheduling of tasks, better sizing of these tasks for reading. A lot of really careful work towards performance improvement. And let me also try to show it for you, just on some example, because it is so nice. Let me go to a server. Here is one of the servers. I will run ClickHouse local as usual, version 25.9. It is basically master version after 25.8. And what do I want to show? I want to show you some query that became much faster. I mean, a lot faster. Where is... I see it. I will just copy paste this query. It's pretty simple query, just a single filter by a substring sorting and limit. And the first run will be without this new optimization because it is very new. It is just introduced a few days ago. And it is available under a setting that you can enable to explore this feature. So the first run of this query was 7 seconds. I will run again just in case. And this is what we did have, 7.4 seconds. Now I will do a magic setting, something like Parquet v3. Let me try to find it. Here it is. Input format Parquet, use native reader v3. How much faster this query will run? Mark, would you like to guess?
Let's see. Well, so we said it's on average, what, twice faster?
1.8, actually, less than twice.
1.8. So it's gonna should be 3 to 4 seconds.
We will see. Probably arithmetics is the best. You said
Oh, close.
you are absolutely right. It's actually it's a massive speed up because the implementation of Parquet was also already really good, but there is always an opportunity to squeeze more performance. And I remember, like a few months ago, people from Data Fusion bragged about they did slightly faster than ClickHouse, but now we did much faster than Data Fusion. Okay, let's back to the presentation. And this feature is interesting to explain. Speculative retries for Azure. ClickHouse can work on AWS S3, GCS, which is compatible with AWS S3, Minio, which is also compatible, or you say MinIO, I don't know, but also Azure. And Azure is different. incompatible blob storage. And the problem is that if you take a query like select query, and you care about, let's say, 99.99% percent of latency, like you care about a single query out of 10,000, but every query can do a lot of requests to S3 or Azure. A typical number like 1,000 of requests. Obviously, in parallel, these requests are parallelized, but then what should be the latency percentile about every single request that you do to AWS or Azure that you should care about? If I calculated correctly, if I multiply these numbers, if you want to care about median time of your query, not median, like 99.99, and then you should care about every single out of million of requests to S3 or Azure. And someone would say, why do you worry about just a single request out of million? But apparently it is very important. But what is the problem with Azure? With Azure, we have noticed that sometimes, not frequently, just occasionally, a certain query runs for 5 seconds. It should be less than 1 second, less than a half, but it runs for 5 seconds. And about this time, like 5, but sometimes 10 seconds, sometimes even 15 seconds. And first we looked at the code base where there is sleep 5 or timeout 5 or retry after 5 seconds, and we did not find. The problem is latency is inside Azure. I don't know why, but we have to work with this complex distributed system. And we already solved this problem for AWS using multiple connections to multiple endpoints, switching these connections, rotating them every time for better distribution, running speculative requests, which means run one request, wait, but then be impatient to run another request to another endpoint. Wait just like 50, maximum 50 milliseconds and do a second request. And this is actually a recommendation from AWS engineers, and it is totally natural. You don't have to worry to do it. Do it aggressively as you like. But for Azure, we used just the stock implementation of HTTP Azure SDK, and it was not customizable. And we dropped it. We ditched it away. We changed it to our own implementation, and now rare latency spikes just gone. There are no more latency spikes. And Azure now works as fast as AWS, sometimes a little bit faster, sometimes a little bit slower, but for different reasons. And it is actually a big deal. Okay, what else? Faster secondary indexes, faster filtering by secondary indexes. Sometimes you are wondering what type of secondary indexes to create, how many secondary indexes to create. In this example, we have a table, we have a user field and a text field. And for user, I have index of type set with granularity 5. And for text, I have a Bloom filter index with another granularity. And actually, it's very difficult to understand which index to use, in which order. Actually, we use all of these indexes. But until the latest version, we used the first index, filtered by the first index, and then the second index. And it was clearly suboptimal. The optimal way, which is in the new version 25.8, is to read and apply indexes in the order of their compressed sizes, which means lightweight indexes will come first. Heavyweight indexes will go next. And this decision is even done for each part individually. So for one part, it could be reasonable to use one index first, for another part, another index first. And the most importantly, you don't have to afraid to add another index. It will not slow down queries that filter most of the data by existing index. These queries will continue to use the existing index first. And this is an external contribution from Anthropic, which is one of my favorite ClickHouse users and customers. Now about something interesting. What do we have? First of all, about experimental features, like lightweight updates, introduced just one version ago. And now they are not experimental. Now they are beta, which means the format cannot longer change. Every change will be backward compatible, and we just collect user feedback from you. So what does it do? Now we have full-featured update statement, and it is lightweight. It is implemented not by full data rewrite, not by storing expressions, but by storing patches, small patches that are applied on the fly. Another experimental feature that is no longer experimental, it is graduated to beta, correlated subqueries. We introduced correlated subqueries just recently for many types of correlated subqueries, and the TPC-H test suite can run without modifications. We found some issues, fixed some issues, we collected feedback, and now we can say confidently that it is no longer experimental, it is in beta. What about data lakes? And actually, this is the most massive improvement in the release. There are so many improvements that it will be even difficult, very difficult to explain, but let me start. Support for deletes in Iceberg, positional deletes and equality deletes. And not only for data that is already was deleted in recorded as deleted in Iceberg, like you used Spark to do these deletes to form this data. You can also run alter delete statement from ClickHouse. You can write into Iceberg using catalogs. So catalogs automatically represent tables that exist in the catalog. And you can write into these tables from ClickHouse. You can also create a new table, a new Iceberg table, not just attaching existing tables. So ClickHouse becomes more and more self-sufficient for data lake landscape. And obviously, you can also drop table using REST or Glue catalogs. And this is not all that we have. We have even more. Now we support also writes to Delta Lake tables. I don't know if Delta Lake is still fashionable compared to Iceberg, but we see a lot of customers using Delta Lake for one or another reason. And time travel. Time travel is also supported for Delta Lake, now in addition to Iceberg. Let me just summarize it with this slide from my friend Melvin, who is a product manager in our team. Just about half a year ago, we had nothing. Now we have everything. That easy. There are still something to do, but you get the slide, right? And to celebrate all of this, we promoted the data lake catalogs to beta. Until recently, they were experimental. Now we can celebrate they are I would say almost production ready, which means, yes, none of the syntax compatibility will could break. We will have to keep it and promote to production, hopefully, in the next version. And we have all possible catalogs supported: Unity catalog, REST catalog, Glue catalog, Hive Metastore catalog. And did you know that with Unity catalog, we support something that is named uniform tables? And uniform tables is a concept that you can have the same data, but the catalog will represent it as iceberg or as delta lake, as you like. And you can use writes to iceberg, writes to delta lake. So any interface in your disposal. Okay, as a bonus, we have a guest speaker, but first let me introduce. A question. Do you like MongoDB as much as I do? Mark.
That sounds like a trick question though, because the only database you like is ClickHouse.
Yeah, I like ClickHouse. I don't like MongoDB. But you know what I like? I like when data from MongoDB magically appears inside ClickHouse. Let me stop sharing and give a word to our guest speaker. Welcome, Joy.
Thanks, Alexi. Hey, everyone. I'm Joy, and I'm engineer on the ClickPipes team here at ClickHouse. Now that you've seen all these amazing amazing features, and if you're first time to ClickHouse and you're super excited to get started on getting your Mongo data over to ClickHouse, this is the presentation for you, as well as if you're just curious about to learn more about our JSON data types. So yeah, I want to take this opportunity to share with you our MongoDB CDC connector in ClickPipes launch. It's currently in private preview. This will allow you to continuously ingest data from MongoDB to ClickHouse with just a few button clicks. And with that, I will show you the few button clicks. Let me share screen real quick. Sorry, one sec. Okay. Cool. Now you should be able to hopefully see my screen here. Here I'm in the ClickPipes data source page. For this demo, I created a data set in Mongo Atlas. Here we see it's a bunch of basically just purchase orders from customers. We have an order ID. We have some nested object, including things like the customer's address, name, ID, items on the things that they have purchased, and the order summary, how much money they spent on their shopping cart, let's say, and then timestamps and some metadata. And this table consists of 1 million documents, so it's not too big. It's 184 megabytes of compressed storage. So yeah, we want to basically replicate this data over to our ClickHouse cluster. All right, so to get started, here you can see we have the MongoDB CDC tile. If you have not signed up for a private preview, once you click this button, it's going to lead you to the private preview sign up page. Otherwise, you will see the connection page. I will give it a name, demo, and pasting a bunch of the URLs, user, and password. And for read preference, this is MongoDB concept where you specify which node you want to read from. In this case, we typically default to secondary preferred, which means it will read the secondary node by default. And in the case the secondary node is not available, it will read the primary, or if your instance only contains a single node in Mongo, which is a very rare case in production. So we'll leave it at that. For replication method, we'll have both initial load and CDC. Cool. I'm going to update the sync interval to 10 seconds, which just means that at a 10-second interval, we'll try to do the data sync from MongoDB to ClickHouse. Leave everything else as is. And here I'm going to, one thing to note is we want to sync the data as JSON data types. If you don't select this, it will be stored as a JSONified string, which somewhat deceives the purpose of having a JSON data type, but we kept this feature for older versions of ClickHouse that don't support JSON. Cool. And then for the purpose of this demo, we're just going to replicate this table here, give it the access, and we have started to create this pipe. So you can see here, the pipe is provisioning. Once it finished provisioning, it will turn into go into the snapshot mode, in which case it tries to get initial snapshot of the table. And here we are. And once the snapshot is completed, it will go into running phase, in which case it's doing CDC updates. While we're waiting for this, I'm just going to kind of walk through a few features. Oops, one sec. Sorry. Walk through a few features for us. Cool. Yeah, so in terms of the features that our MongoDB CDC ClickPipes supports, we support all the change events, including insertions, updates, replace, and delete event, which are all the change events that MongoDB provide to us through their change stream API. If you don't want to do CDC, you can also do a single one-time snapshot. For example, if you just want to migrate a data set over for testing purposes, or if you want to, or for any sort of other reasons. We support flexible schema changes. As you know, this is the power of MongoDB with the flexible or the schema-less sort of world. And in the ClickHouse, because we're using the JSON data type to store the document, we now can get all of the flexible schema changes within our ClickHouse data types as well. We support both replica set and sharded cluster. So you can have a very large sharded Mongo cluster and still being able to create a single pipe to basically replicate your data. You can, after you create a pipe, you can edit your pipe to add and remove collections as more tables gets added into your pipe. And just like our existing Postgres and MySQL data source, we support everything like resyncing a pipe if you want to rebootstrap your table. We support private link and all the standard metrics, logging, monitoring as well. Last, because we built everything on top of PureDB, it's completely open source, so you can check out the code there as well if you're interested. Cool. All right, so before we get to that, now that we're, I think our table should be ready. Let's go back here. Yeah, cool. So it's running. Actually, I don't think it took that long. If we take a look at the actual table, it's 1 minute and 40 seconds to run the initial snapshot on this table. And here you can see loggings and setting is where you kind of, if you want to, as I mentioned earlier, add a table, remove a table, update your username and password if your credentials have changed, things like that. Cool. Now that you've seen this, the next thing I kind of want to show you is some more performance side of things and also just what the JSON data type looks like in ClickHouse. I'm going to first log in to MongoDB through the Mongo shell, just so that we can see the data again as before. This is just a query that gives me a sample data from the Mongo side, so you can kind of see the data structure more clearly. And then let's open a new tab here, and I'm going to start a ClickHouse client as well. Cool. Yep, so as you can see, our order tables is now in the database. If we just want to see what a typical data looks like. Actually, before showing you the data, I do want to show you the schema. Yeah, so here you can see that, sorry if it's not too big, I'll do it again. Here you can see that the way we replicate the data is just with the ID, which is the document key, as well as the doc field, which just represents the entire document in JSON. And then the rest of these are the standard PureDB sort of like metadata columns that we use to keep track whether the column version and whether it's deleted and when it's synced at. So let's take a look at what a single record might look like. Yeah. So here you can see that the data is stored as a JSON blob. So you might wonder, how do we query the data here? And because our JSON supports dot syntax, it's actually really easy to run queries on top of the JSON columns. So here, if I want to access a super nested data field from the order tables, I can do something like this. Oops, and this actually gives it for every single row. So maybe let's just do, yeah. So now you can see that we're accessing the individual field within the JSON data type. And one thing worth noting here is if you try to run something like like a summation over this data, you will get an error telling you that illegal type dynamic. This is because all of the JSON fields are of type dynamic. So you do have to run a cast here. Yeah. And now you can see that you can basically access the data right here directly. One other thing I kind of want to show is, yeah, so if you want to see what the dynamic type is for a particular field, you can run something like this, copy paste to be fast. Here we're just calling the dynamic field of this particular field. You can see that it's actually stored as an int64 in this case. I use distinct because to show that in this case, the schema is consistent, but it does support multiple data types if that's what your data looks like. And finally, the one thing I kind of want to show, and the reason I had both table open here, is that on the Mongo side, I'm going to give like a pretty standard like analytical query here. So what this query on the Mongo side is doing is we want to get the month with the highest sales, and we want to see how many unique customers have contributed to that sale that month. And the projection just give me the months, the sales, and the unique customer fields, sorting in descending order. And then basically extracting the maximum field, the maximum row or document. Yep. So I ran this query, and in this case, we got this result back. To show kind of how long this query took, I'm just going to run it once again with the execution stats. This kind of enables the query planner, and it provides me the field on this. And what I'm specifically trying to show you here is if you look at the execution stats, this query took 3.25 seconds, and it scanned the entire data set. Over here, we're going to run the exact same query in, at least logically, the exact same query in ClickHouse. And it looks something like this, where we get the months, the sum of the sales, as well as the unique customers. And yeah, it took 0.26 seconds. So MongoDB was never really designed for analytical queries. So this is why it's awesome to kind of have the ability to use ClickHouse to be able to run analytical queries like this, especially things like aggregations. And that is the demo. The final thing I want to say is that because this is just private preview, there's a lot of the features we're still working on. We're working on introducing a flattened table in the case where you want to be able to more simply querying the data without worrying about casting. We can handle all of the flattening of the column for you as well. We're also introducing custom order key. I don't know if you noticed earlier, but the default order key is just the document ID, which if you want to optimize your query as the label table gets larger, we want to be able to provide that to you. We want to also improve our parallel initial load to support larger data sets, so it doesn't take too long to run that initial load. Deep merge JSON is an interesting one. This is where we want to be able to not do a lookup in the Mongo database in order to provide the full document. This is because Mongo's oplog by default only contains the changed column or the changed fields. It doesn't contain all of the fields. So in order to hydrate each change events, we have to essentially query by we, I mean the change stream API on the Mongo server side has to do that query, which adds a little bit of a load on the database. Whereas with the deep merge JSON, the idea here is we can hook this up into the coalescing merge tree so that we can constantly merge the fields as the change events as they arrive, so that we always have kind of the latest view of the full events. And this is something I'm particularly excited about because I haven't seen it done anywhere else. And then yeah, the open API support and so on. And if there's any other features that I haven't mentioned here that you are interested in, please feel free to let us know or try out our connectors. And that's all. Thank you.
This looks really good. Now let me ask you a question again. Do you like MongoDB as much as I do?
I still don't know how much you like MongoDB.
Okay. I will not tell this secret. Okay, now back to the main presentation. What else? When you use ClickPipes, you can set up vertical scaling to speed up as much as you want streaming consumption of this data. If you have a lot of data, you can set up as fat pipe as you like. There is support for Azure blob storage. So until recently, it was about S3. Now, if you have your data in Azure, you can also use ClickPipes to consume all of this and put all of your favorite data into ClickHouse. There is a change for Postgres, change data capture. Now it supports the JSON data type, official glue connector, improvements for Python. Okay, a lot of things. And one more thing. In ClickHouse Cloud console, you will find, if you will be lucky, you will find, if you're not, you might ask and we will give it to you, a tiny button named Click Stack. And when you press this button, you will find a fully featured observability UI, where you can analyze your logs interactively with Hive-style, with charts, diagrams, dashboards, and everything. It is really powerful, and I use it. I use it for crash telemetry about ClickHouse. Meetups. We have meetups all over the world, and I will be on some of these meetups in person. I will not tell you on which of these meetups. You will have to guess. a lot of interesting stuff in our blog, especially about AI. Everything is about AI. So if you are not too bored about AI, you can read about comparison of different chat UIs like LibreChat or any LLM, if it's named this way. Business intelligence right in Slack. Observability with ClickStack, text search, everything else. And now we probably have 1 minute for questions.
All right. Let's see how we can do. So, one of your favorite questions, when will the release be on Docker Hub?
I think today, maybe tomorrow. It is being built right now. We pushed the latest changes, and it will be hopefully.
Then there's another question about a PR for improving the performance of JSON subcolumns reading from shared data in merge tree. And I think it says it's going to be in 25.8. Is that right?
It is in 25.8, and we have so many performance optimizations that I did not even have a chance to include this into the release call. We also have an optimization for group by and a quite wonderful optimization for joins, and even major features like vector search. It is in GA in version 25.8, but 1 hour is not enough to tell about every new feature.
We'll have to do it in the release blog. Should we do probably next week or the one after? We'll see when it gets published. What else? Yeah, I mean, yeah, those are probably the easiest general questions. So I guess we can probably wrap it up there. We're a couple of minutes past already. Any final words, Tyler?
Yeah, indeed. I'm slowly being kicked out of a venue. So apologies for the binging sounds in the background. Thank you all, as always, for joining us. Enjoy. Your demo was super exciting. I was really glad to see it. If you have any questions or feedback, please feel free to join us. ClickHouse.com/Slack. Download the release, try it out, and we'll see you in the next month. Cheers. Be well, everyone.